What's going on, everybody? My name is Samir Azizi, and welcome to Azizi Podcast. We have another episode dedicated to AI, decentralized compute, and of course, we are here with Dr. Mehdi Kargar. Hi, sir. How are you?
Hi, nice to see you, Samir. Thank you for having me.
Of course, thank you for your time. You are, of course, the contributor to Heisenberg Network, and full disclosure, we are working together right now on the project, on the startup. And I wanted to have this conversation with you because I'm actually really, really curious, and I want to learn more about the company because I want to make sure I know how to help it better. So, with that being said, I had a conversation with Maury, your co-contributor and co-founder of Heisenberg Network. And I've grilled him a lot about like how did it all happen? How did it click with you? What's your background on like this whole engineering stuff? And I kind of wanted to go through the same thing with you, kind of like ask your side of the story. So with that being said, I wanted to ask you where did the idea for Heisenberg come from your point of view, and was there a moment where everything just clicked to you and Maury?
And it's funny you mentioned that. I actually haven't watched the interview with Mori intentionally because I wanted this also to be very authentic from my point of view.
Love that.
So there might be a little bit of maybe not full agreement between my version and Mori's version, but here's my version. So when we started, we wanted to build some tools, some analytic tools for the Web3 builders to basically bring predictive analytics to their product. Let's say like you have a wallet, like you're building a wallet, and in your wallet, you want to recommend some tokens to the people who use your wallet. This needs obviously like some predictive features. You want to look at the current holding of the wallet owner, and then based on that, you want to recommend some tokens to them. This is a very Web3 native kind of product or require. So we were thinking to build basically tools to make this very easy, to make building predictive features only for Web3 products. That was the the first vision at the beginning. And then we started like talking to people, and then we realized that, well, this is obviously a need, but the issue was that the predictive kind of analytic in Web3 was not a very, very big domain.
Mm.
That was one issue we saw. And at the same time, we also realized that, well, this is something that's obviously needed beyond Web3. If we can make building like predictive features, models easier in also Web2 domain, that would be very useful. So beyond Web3. And from there, we kind of started to look into, okay, how people are doing this in Web2. And we realized that for the past few years, it's kind of interesting. I don't know why in, for example, 2010s to 2020, not too many people were doing it, but from 2020, 2021, probably after COVID, people started to build products to make it easier to build models, specifically on the data layer domain. So what we noticed for a product, for example, like SageMaker from AWS that allows you to kind of like easily bring data to your model. For example, your model needs raw data. The raw data needs to be pre-processed, cleansed, and then be ready to be consumed by a model. AWS SageMaker does that. But what happened is it's very expensive, very pricey to use these centralized services like AWS. And obviously, we were in the Web3 domain. So we started to brainstorm, talk to people, and then we realized, well, you know what? The Web3 basically like democratized the whole compute. And it does it in many other areas, but nobody has done it in this particular data or intelligence layer. Nobody has looked into, have a lot of raw data. How can I convert it into intelligence or distilled AI ready data? And that basically became the core idea of Heisenberg.
That's interesting. And you mentioned, several issues that you're solving here with Heisenberg. And it feels like the first one is like no one is doing or like very little attention is being paid to the predictive data. And you kind of started with Web3 as well. And so that's kind of I'm curious about that. Like we went for the jugglers right now for the most like speculative industry, right? But there's like lack of attention in the predictive data, but also you're mentioning cost. And so like in your opinion, like right now, there are a lot of problems in AI space. Would you say it's mostly because of the cost compute, or just like people are not paying attention to something else?
I think both. There's one thing for sure that people are not paying attention to. Okay, you do have these nice LLMs. You can ask any question from the LLM, it will answer you. But if it's not hooked with the right type of intelligence or AI-ready data, all of them will end up doing the same thing because all these LLMs, we don't have like too many LLMs. We have a handful of them, like from Llama, from OpenAI, from Anthropic, from DeepSeek, but we don't have too many of them. We have few of them. And if you don't like enhance them, supercharge them with the right intelligence, all of them will end up doing the same thing.
So it's like on the market right now, we have this couple of blobs of data, just like, and they just drop it in your startup, and they just drop it on you to work with. And you're just like, on the surface, it looks like we talked about it before as well with Maury. Like on the surface, it looks like, okay, well, it responds to the right questions. It looks like it's like thinking and stuff, whatever. But if you dig deeper, that blob is like, it's very hard to go through all of that data to actually get to the core, especially if you're in a very niche industry.
And
Am I correct in that?
yes.
That's interesting. And so with the data stuff, like you mentioned data layers, like why is data layer such a big deal in AI? Is that like thing that solves it? Like, and why are so many projects failing because of it? Is the blob thing like to go through that? Like, can you elaborate on that?
Because it's actually pretty hard and painful to take raw data and then convert it into intelligence. And it's not just you do it once, you have to constantly doing it. One simple example, for example, let's say you want to build some sort of like a recommendation engine, for example, using Uniswap data. So what does Uniswap data have? Uniswap data have individual transactions that this token is converted into this token, like USDT is converted into ETH or Link, something like that. And I actually checked. On average, like usually every week, Uniswap has more than 1 million transactions, at
Okay.
least 1 million transactions roughly. And if you want to build any predictive model with these 1 million transactions, there is no way that you can pass this to an LLM, at least as of now. No
Just
LLM
because
can
it's too much, right?
too much. It's very raw, it's very fragmented. So how can you get any sense out of it? You have to aggregate it. For example, you aggregate it at the token level and says, for example, link token, this is the amount of inflow, this is the amount of outflow, and then you can create some metric based on that, right? But the thing is, first of all, you have to build this kind of platform framework to convert these raw Uniswap transactions into AI-ready intelligence, and you have to keep it up to date all the time at very short intervals. Because
Right.
when it comes to inference, you want to have fresh data. You don't want to look at like a week old data or a lot of time even few hours old data and then make a prediction about it. You want it to be very fresh. So then keeping this up to date also at short intervals will be very costly.
So, how I understand it then, and I'm just trying to also kind of educate myself here, is that instead of getting like all the raw data on the crypto transactions, or like in my mind, like maybe it's like a metadata with which like not just the important parts, but also all the other things, like all the like keys and addresses that are not necessarily needed for this particular tasks. Uh, what the data extraction is doing is just getting like couple points that are actually important, and then disregarding everything else and therefore not using all that compute and just like, and that's kind of like the key aspect what's happening here. It's like you are just picking the ones that are important and then using those instead of taking the whole thing and then trying to go through that and therefore like spending all this money on the computer. Is
In
that
that
correct?
particular use case, you do a lot of aggregation. So you do
Hmm.
want to have like insight about probably most of the tokens, but meanwhile, you also remove probably tokens with very few number of transactions. So you do like a lot of filtering, you do also a lot of aggregation.
Hmm. Interesting. And is that what's called data agent? The thing that does that?
This is one instance of it, yes. So
And
the
so
data agent, yeah, sorry, go ahead.
yeah, I just wanted to ask more about it. Like let's simplify it for our listeners. Like what exactly is a data agent and like Heisenberg network?
So a data agent is basically an agent that takes raw data, perform any kind of pre-processing, cleaning, aggregation, even vectorization, apply embedding if we are dealing with text data, and then prepare like a distilled clean data, or we call it also intelligence,
Hmm.
that's ready to be consumed by a model. In most cases nowadays, the model would be an LLM. So that means data agent basically takes raw data and then convert it into intelligence. This
Hmm.
intelligence then becomes context for an LLM in any domain.
So it's like, it's funny, like when you say it like this, it's like, okay, like something data gets cleaned up, right? And all of that. But it's like, it's easy kind of to imagine in like a simple level, but like I'm maybe we should go a little bit deeper. Not too much, I'm not super technical, but like and maybe my audience wants to like understand it better. But like what actually happens between this raw data and AI ready intelligence in your system? Like I know it's getting filtered and cleaned up. How does Heisenberg handle that process like maybe like in a deeper level, like if you can explain to me?
Let's stick to this Uniswap example. I think through the example, at least for me, whenever I listen to a lecture, interview, podcast, whenever like there's an example involved, it's easier for me to follow. So let's focus on this Uniswap data.
Sure.
You have the raw Uniswap data, and you can get it from the chain directly, or you can get it from some providers, for example, like Dune Analytics, Flipside, any other providers. So you take the raw Uniswap data, and then in our case, there's a Python SDK that basically is written. At the moment, it's written by us, like the core Heisenberg developers, but in the future, we will open the door to other developers to develop their own data agent and monetize it. But at the moment, it's developed by us. So we use our Heisenberg SDK to write Python code to convert this raw Uniswap data into any type of intelligence that the agent want to consume. As I said, one example could be you want to build intelligence for token recommendation. So you want to probably aggregate data based on the volume inflow, volume outflow, number of transactions, for example, per token. And this is all done by our SDK. So the SDK is taking care of this conversion of raw data into intelligence. And then somebody also has to actually run the code, right? You
Hmm.
have to run it on a machine. And this part is done on the Heisenberg nodes. And that's where people can install our desktop app and monetize it based on basically kind of we rent their idle CPU to do this compute. So we basically take care of the whole kind of framework end to end. We have the SDK for basically doing like running the code, and then the compute is provided by our CPU network.
So the code itself is where it is, like the conditional kind of like okay, if then type of thing where it's like this is what we're dealing this with what this is what we need to extract. So the code kind of acts as like a set of rules. And now to run this code, you need to go into, you actually have to have some sort of a fuel for that. And that's where the decentralized compute's coming in. And I wanted to ask you about that. So Heisenberg network is a decentralized network. And why did you go this route instead of just centralizing everything? And just for the context, that we will be talking about decentralized CPU and people contributing their CPUs all over the places through their laptops to Heisenberg. But like, why did you go that way instead of just having full control of that?
The main reason is the cost. It will be cheaper if the community provide their CPU. It's much cheaper than going to centralized providers. And the reason is because we use like 10 to 15% of every computer CPU, whoever install our desktop app, we don't want to interrupt their daily life. So we only take like a small portion of their CPU usage in a distributed way. We use that. So it basically brings the cost down significantly. That's number one reason. The other reason that might happen is also it's kind of more flexible. If you do it in a decentralized way, you're kind of like protecting everybody from censorship. This is kind of like the second benefit of it. The main benefit, again, is cost, in my opinion, as of now.
Mhm.
But the second benefit is also this decentralized setting always kind of protect you from censorship, from somebody telling you this is what you can run, this is what you cannot run. If you have it in a decentralized way, well, it doesn't like not one entity controls everything.
That's interesting. And the cost aspect is really interesting to me because I don't know, maybe as a former accountant, I'm like, I'm curious about those things. But how exactly does that save you cost? Like, how exactly does it decrease cost? Like versus like if you're using like AWS or Google Cloud or something like that. What happens? Like, why is it cheaper?
So the reason it's cheaper is because AWS, Google Cloud, Azure, they have a lot of overhead cost to run their computer and their nodes. They have like huge data centers, they have a lot of engineering teams, all of that. These cost eventually adds up, plus the
Mm,
cost of like they have to also add their
ov-
profit on top of that.
overheads and markups,
A
basically.
lot of overheads, a lot of engineering costs. And I'm not saying they do a bad job, they do a fantastic job. Obviously, that's why they have millions of customers.
Right.
But if you can at least do some of the tasks, like for example, for our case, most of the tasks are CPU intensive, and there's millions of CPUs out there. And most of the times, these CPUs are idle. And as I said, I don't want to use 100% of the CPU of each computer, around 10%. So I
Mm.
don't want to interfere with people's daily life, but I'm just saying if somebody's CPU is sitting on their desk, I can tap into it, use that ideal CPU, get some data processing job done, and then share the revenue with them. But I don't have a lot of overhead cost of the centralized platforms.
That's amazing. And as far as cost saving, would you say like what's the like 2x, 3x? What's the rate of cost saving,
I
would
would
you
say
say?
at least 2x based on our experiment, around like 70% based on some experiments we did.
And so let's talk about it a little bit deeply. Like most people talk about GPUs, like when they talk about AI, but Heisenberg is all about CPUs. And can you kind of like elaborate on that? Why is that important? How does it work? It sounds like it's counterintuitive. It's like we were all going nuts about GPUs just over the past 3 years, and now Heisenberg comes in and is like, well, there's also a CPU route. And could you explain that to me?
So the main reason is because the nature of the task we do, the nature of like these data agents that take raw data, convert them into intelligence through different processing, cleaning, aggregation. This type of task is very CPU intensive. And to me, that's the beauty of where Heisenberg focuses. Other people that focus on GPU, the main reason is because, especially with these LLMs, with deep neural networks, it needs a lot of training that definitely needs GPU. It would be very slow with CPU. But also when it comes to inference, like if you want to run a model, run a, for example, an LLM, like when you answer questions from ChatGPT, it goes through a neural network, the LLM neural network to get the answer done. That one needs also GPU. But for us, we're kind of the step before you get to inference. So as I said, Heisenberg wants to provide context for these LLMs. And this context is provided by running like tasks that are very CPU intensive. I would say fortunately for us, and that's why we are focusing on it.
You know, you say inference, and I'm just gonna digress a little bit on the different topic. I was on the X yesterday, and someone posted. Everyone's posting pictures right now there because we have all that Ghibli type of style stuff. But there's like 4.5 model on ChatGPT, and someone asked like in the pictures, explain like how do you feel as an LLM to ChatGPT, and it made like a picture where it says like, well, I'm only alive when you run inference, and then I die, but then I'm born again when you do it again. And like the guy's like, I had goosebumps when it gave me that picture. And it's like, you know, I don't know. I just wanted to kind of mention that because that was kind of like a crazy thing where ChatGPT says I'm only alive when you run inference on me. But there's that. What do you think about that, by the way?
I think it makes sense to me.
Yeah, like logically, like of course.
There's no inference, there's no ChatGPT.
Right, right. Okay, so if I'm in an AI company, artificial intelligence company, what's the biggest benefits of using Heisenberg instead of trying to build something in-house, right? We're not talking now like switching to something, but like how's Heisenberg plays as a service to this company?
Let me tell you why our early adapters want to work with us. One reason is we save a lot of development cost for them. Because as I said, at the moment, we are building these data agents for early adapters. So that's very attractive to them. They find it very useful because they don't have to assign a team of engineers to develop these pipelines. And in the future, as I also mentioned, we want to open the door to other developers to build data agents and monetize on Heisenberg. But definitely development cost is one reason that attract people and early adapters, and we believe that it has a huge market. The other one is the compute cost. as we talk about it. Like we will bring the cost down significantly. If you want to do the same job on centralized platforms, it will be at least double the price.
So, um, that does that mean like you do like Heisenberg does a customized data agent based on the client's needs, right? Like the client comes in, it's like we need this type of data, and it needs to be clean and nice and crispy. And
Yes,
Heisenberg does like the whole refining then on the background based on the needs of the client
yes,
or the
very true.
company, whatever. Okay, great. That's actually pretty clear and makes a lot of sense to me. But like let's get back to like nodes and how people actually run this data to Heisenberg. Anyone can run a node on their personal computer. And so what kind of work is that node actually doing?
So basically what happens is when you install our desktop node, behind the scene, the software will come up. We will have a Docker instance running on your computer. And the good thing about Docker is we can fully control the amount of CPU that it uses. So as I said, around 10 to 15% of the CPU. And you don't see anything behind the scene. Like behind the scene, well, in the front, all you see is small Heisenberg app that shows the amount of the number of points you have so far. And you can obviously, if at any moment decide not to run it, you can also press a button and then you suspend the Heisenberg app. But as long as you are okay to run the Heisenberg desktop app, the Docker behind the scene runs. And then we basically like Heisenberg send the type of job that needs to be done. And then the node basically run the code, get the raw data, apply any pre-processing, cleaning, aggregation that needs to be done, and then send the aggregated clean data, or we call it intelligence now, intelligence back to the destination. But the end user, like the non-technical user especially, they don't feel anything. It's just like a normal software. Obviously, we never touch anything from their computer. It's just like we bring a Docker instance up and running, use a small percentage of their CPU, and then everything happens within the Docker instance, which everybody knows is pretty secure.
So I'm glad you brought it out, the privacy perspective and security. From the privacy perspective, what protections are in place for someone running a node on their laptop?
So we never touch anything like private on people's computer. We never look at their files, their content, their browsing history, nothing. All happens is the Docker instance is brought up, and then everything is done through the Docker. Like the type of data they need to, I mean, the node or the CPU needs to process, it's all sent to the Docker. And after the processing is done, the result is also back through the Docker. But nothing like from the user computer, user file will be touched, will be looked at. We don't need it. We definitely don't do it. And we have very strong security system that it never happens.
Got it, got it. And so, I mean, it sounds like a great sweet deal, right? To install Heisenberg node and just run it on the background. And it's so I predict like with the launch, it's going to be like accelerating really fast. People will install it and just run it. So as the network scales, how do you make sure that it remains fast, reliable, and secure? Because it's going to be like thousands, hundreds of thousands of people just doing this at the same time.
So we have these kind of servers, we call them dispatchers, that basically distribute the job to the nodes and then make sure that the processing is done, the compute is done, and then kind of make sure that when it's done, the result is back to the destination database. So at the moment, we are basically like Heisenberg Network is the one who build the dispatcher and control the dispatchers. But down the road, we definitely envision to kind of decentralize the dispatchers too. So
Hmm.
we will have different like companies, different players that apply, and then they basically become dispatchers too. And it's even cooler that I also envision that in the future, people can maybe even stake tokens to these dispatchers and kind of like vouch for them. So we can basically add more dispatchers, and the dispatchers will make sure that everything is fully decentralized, very scalable. More end nodes, more desktop app come to the network, we can deploy more dispatchers.
Yeah, yeah. I just had a thought. What if like, and that's just my question, because like from the assurance perspective, what if we have so many nodes running And now we have clients as well on the other side, right, for any sort of companies. And then they really need a lot of those nodes, that CPU, like there's demand, huge demand. But somehow like there's a falling off on the supply side, right, for the CPU nodes, like something like, let's say a lot of people are running their nodes in the province of Alberta, and then Alberta just like shuts down or something, like something happens with electricity, like their laptops are not working. How does that work? Like, is that it's gonna be a problem, or like when there's like a bulk of laptops just unplugged for some reason?
Well, I think because of the decentralized nature of it and the distributed nature of the system, unless like half of the nodes go down, like if a small percentage of a node, especially in one region, goes down, it won't affect us a lot because we
Hmm.
also try to distribute geographically. As you said, there is possible that like there is some shutdown in the electricity in one region. So that's why like we intentionally, when we build the system, we distribute it wisely. So it
Right.
doesn't go like one job doesn't go to only one region. Obviously, we also have replication in process. So not just one node will do one job, multiple node will do one job. Especially in our case of like running on desktop nodes, you never know like when somebody press a button or turn their laptop off.
Right, right.
So obviously we have a lot of replication in place to make sure that everything runs smoothly.
Well, that makes sense. And that actually explains the idea behind decentralization, right? If you're like relying on some one centralized source, it's like, okay, well, let's hope it's like operating and nothing happens, right? But then if it's decentralized, you always have that little insurance, oh, well, we have a couple other nodes doing the same thing and they can pick up the slack if needed. So
Same even for Ethereum network. Sorry to interrupt, Sam. If you think about it, like Ethereum is fully decentralized. But the thing is, there are so many replications, so many nodes up and running. Obviously, the longer the node keeps the server up and running, also the more reward they get. So this is kind of like very common for any decentralized network, and we definitely take all of those design perspective into account.
I love that. And you do provide a lot of comparisons with, well, not comparisons, but like you bring up crypto a lot with Uniswap and Ethereum. Like, are you interested in crypto? Were you interested in crypto before you started Heisenberg? Like, was that because it was like an original use case for you guys? What's your background on crypto? Just curious.
Well, I started like looking into crypto around 2017. I was even a victim of one of these exchanges like collapsed. If I'm not mistaken,
Which
Quadriga.
Quadriga? Yeah, yeah, yeah.
Yes, I was one of the victims.
Oh no.
And then after that, like for a while, I actually wasn't a fan of crypto. But then during COVID, crypto started to be more popular. I started to educate myself more and more about it, talk to more people, actually listen to podcasts like yours
Mhm.
and others. So then when you kind of like start to digest it and you see like the benefit, the huge advantage of crypto in many, many different domains. And because in my experience, like my expertise as a researcher is in data management, I could see like the benefit of having a decentralized system backed by crypto and blockchain for the type of job that I see like very valuable. So that's how I was kind of brought into this space. And the more I move forward, the more I love like the space, the people. I think there's a lot of like very, very smart, sharp people in this space building and basically like democratizing a lot of different domains.
And that's yeah, I completely agree with you. But I also wanted to kind of ask you, like, besides crypto, like you provided a couple examples in the crypto field, but I also look at the like AI market right now, and there's a lot of non-crypto AI products or AI demands, I would say, not products, but demand for AI. And so, like, as far as ideal builders or teams that should be looking at Heisenberg right now, like, who would you say, besides just crypto, like, can you provide anyone else, like, as like an example for that?
Absolutely, yeah. So a lot of other companies we talk to as early adapters, they are companies who basically like allow people to build AI agents. Like for example, agents who post on Twitter, post on Discord, even like some of them just have like a customized chatbot. All
Right.
of these like are under this umbrella of AI agents. So what Heisenberg can do for them, we can also supercharge them with intelligence and AI ready data. Like for example, imagine you have an agent that's a political narrative agent. It basically gives you some analysis of the news, and you can supercharge them by accessing them news from CNN, ABC News, Fox News, depending on the type of agent they want to build. Even you may have like an agent which is like progressive Democrat versus like a conservative news agent. You
Hmm.
can also pick the type of like news data you want to feed into them, and then based on that, they
Right.
can basically like provide better context, better information to the user, better post on Twitter, all of that.
Yeah, it's kind of like you're building your own feed in a way, instead of allowing, a social network do the same for you.
That's a
Based.
very smart way of saying it. Yes, we basically like the AI agent can have their own customized feed.
Hmm. Hmm. And so like, does that mean that data agent, like you mentioned the social media news example, um, can you use the same logic then for different industries, healthcare, finance, like construction maybe in some cases? Does that same logic apply? It's just based on the preset, I would say, like however you set your data agent to filter the data. Um, do you see like clients like that? I would say. Question.
Yeah, because the nature of the task is kind of very straightforward. You always have raw data in different domain. It could be healthcare data, it could be real estate data, it could be finance data, either DeFi or TradFi data. And then you want to do some sort of processing aggregation to convert this data into intelligence and AI ready data. And how does this happen? You need two pieces again. You need some code to convert the raw data into AI-ready data, and you need the compute to actually run the code. So the basic transition to other domains is pretty straightforward.
There's this AI agent and then data agent, right? And it feels like, do you see like those two will now be like going forward? It's going to be combination of two always, like they will go alongside all the time because if you have AI agent without good data agent, then your AI agent is compromised in a way, like because the data is like unfiltered. So would you say like now it's kind of like the two and two go together?
Let me give you an example. Are you familiar with Virtual's protocol?
Yeah, yeah,
So Virtual is basically one of these Web3 platforms that allow people to very easily
yeah, like Eliza, like similarly.
few clicks, and then you have an AI agent up and running. But what happened is most of these agents end up being the same. Why? Because if you think about behind the scene, all you can do when you build an AI agent without a data agent is you customize the character
Hmm.
and you pick the LLM. You say, I want my LLM to use Anthropic, OpenAI, or DeepSeek, which most of them eventually do the same thing. So your basically power to customize this AI agent is essentially limited just to how you define the character, which is just like basically a JSON file. You talk about like the characters of the agent, the lore of the agent, maybe some sample post, and that's it. Super, super limited. And most of these agents end up being the same thing because they don't have like they're not empowered or supercharged by intelligence. But few of these virtual agents like AI they are very popular. They have hundreds of thousands of followers and users. Why? Because something like AI developed a very nice data agent in-house, I'm sure by spending of a lot of money, a lot of development time. And this data agent that XPT built, what they do is they basically monitor, I think around, if I'm not mistaken, I read 400 KOLs on Twitter, and they also monitor unchanged data, which is like the Uniswap example I gave you. So this like virtual agent like XPT is the best one for on virtual because of being supercharged by intelligence. But now imagine like any non-technical person, as easy as they build an AI agent, with a few clicks, they can also add a data agent or multiple data agents to their AI agent. Then everybody will basically have this like superpower for the AI agent, and they can like customize it. They can talk about many different topics, all of that.
So it sounds like if you're building the usual AI agent, you preset the data and it's just there. And but if, for example, if I'm trying to create, and I don't know, like I have this idea to create, like I'm into boxing, and I
Right.
want the Yeah. And I wanted to I want to create like an avatar that does boxing stuff on YouTube and just like post clip about boxing. But I also want to make sure that it's contextual. And I feel like there's one thing like, okay, you feed the news articles into this avatar and it kind of like creates a thing. Like that's one thing. That's easy. But like as far as context go, like I feel like, with certain things like, oh, what do certain boxers rank at right now, for example, when you say it certain things and how does it affect the ranking here and there? When you say the news, so you're not just like reading from the script, you're actually providing some critical analysis on the like if the boxer is ranked here and he is like a champion in this division, but like how does this affect his perspective for like another fight and who is his promoter, for example, and how much money will he get and is there even a lot to all of that stuff that is around it contextually, not just the news article, but how does it imply so that you can actually get an opinionated thing that through that avatar. I feel like would that be the job for the data agent to feed that information, that contextual information into my boxing news avatar?
That's a beautiful example. Absolutely, yes. And I'm very excited to hear this because I cannot reveal the name of our early adapter yet. Hopefully soon we will. But this is something we are working on with one of the early adapters to basically enable their agent to define different characters. Even mix some of the characters, like basically bring the data from different characters, different like viewpoint, and then mix them up together and always keep this up to date with fresh data. But the
Right.
example is beautiful. It's actually has a lot of applications.
Well, it's good that we work together so you can now use it. So if Heisenberg succeeds, like what kind of AI future do you imagine 5 years from now?
That Heisenberg is part of.
Of course, like how Heisenberg contributes, right? So with the decentralized CPUs, with data agent, how do you see AI future 5 years from now? And 5 years is like a millennia in our speed right now. But like, what's the future holds for us now?
So the way I see Heisenberg few years from now is at any moment, like I cannot imagine like AI exists without this context. No matter like how advanced the training, the inference is, no matter how cheap it is, like for example, by the birth of DeepSeek, you always need context for your model. And I imagine like, and I hope that thousands of builders use Heisenberg to develop different data agents with different capabilities in different domains. And then a lot of non-technical users, as easy as today, they go and connect an AI agent, pick the LLM. They also, when they create the AI agent, they also easily pick the right data agent or multiple data agents. And with a few clicks, they customize it, but they bring their creativity to the world. When they build the agent, they also supercharge it with the right data. And Heisenberg nodes will always keep that data up to date and bring the intelligence to the world.
It's like Heisenberg Network humanizes AI in a way. Yeah,
Yes, yeah, exactly. That's another good word.
I might use it as a
But humanized too, yeah. Because without like this
the context wise,
without,
the boxing guy, right? That's the example.
yeah, exactly.
Um, I actually want to ask a couple of questions about DeepSeek, right? DeepSeek was like a huge news 2 months ago, I think. But it's so, and correct me if I'm wrong, but what happened is I think there was a huge article that one of the persons that I'm following, and he's following me back actually, uh, he wrote like I was reading it for like hours, and I was like a long one, but it basically kind of explained. No, actually, hold on. What happened is DeepSeek dropped their new model, and they said, "Hey, it's free. It's like GPT-4 and GPT-4o, but it's free, and everyone's using it." And I was like, "Holy hell! Like it's actually true. Like it produces the same type of output." And then there's like a giant article that was published about this, and they open sourced their model as well, and everyone tried to kind of like nitpick and see if it's true or not. And the whole thing here is that DeepSeek is not OpenAI. It's a different company. It's based in China. China has limited access to the GPUs and how much they can import. It's kind of like a political decision where they can't have access to that stuff. And so no one expected China to figure it out. When I say China, I mean DeepSeek as in like Chinese company, but just like on the as like from the geographical point of view. But they did it. They figured it out and they open sourced their model and they said go for it and try to nitpick and go through the whole thing. Um, Bottom line is Nvidia stock dropped significantly. Billions and billions of valuation was of market cap was lost.
Mhm.
So it kind of sounded like, okay, this is not some sort of a fluke. It might be real. And then, I've kind of looked through that and I talked to Maury as well, and I wanted to ask your opinion. When you kind of read about that and you tested out and checked it out, were you kind of like, wow, that's something that we do here with Heisenberg Network as well, as far as like not utilizing GPUs, but going the other route. What was that for you? Like, was that like a alpha signal for you? Like, oh wow, we were on the right track, or like, what was going through your mind?
Yeah, I was, I'm gonna be honest with you. I read about it. I'm like, oh God, I'm worried about all these GPU networks because they won't have like too much task to run anymore.
Right.
Yeah, that was my first reaction. And then, yeah, obviously the second reaction was, well, thank God we're not in that domain. Because as I said, whatever like we do, no matter how good the inference, the training is, you always need context. You always need CPU, you always need data processing. So I'm like, okay, it definitely doesn't affect us. But yeah, I was worried about the people who are in GPU network. But then I think I read also somewhere that DeepSeek is also maybe like releasing some models that you can run on a desktop node.
Hmm.
So down the road, if Heisenberg also decide to expand to inference world, and if someone like DeepSeek allows you to run an LLM inference on a desktop node with CPU, that's even a better news for Heisenberg because we already have the network, we already have all those dispatchers set up to distribute the task. But then instead of running the data processing tasks that are CPU intensive, we can also do other stuff with it. I don't want to get ahead of myself.
Right.
Overall, like the DeepSeek to me was a very good news for democratizing AI. And I think the team did a very good job with developing it. And it's already also in AWS. If you have like AWS Bedrock, you can
Hmm.
also pick DeepSeek model. Even like AWS already incorporated that. I was attending an AWS startup event a few days ago in Toronto. We
Hmm.
were showcasing it, and it's already there too. So not just like on people's computer, you can even like pick it up on AWS and run it on the cloud too very easily.
Oh, next time let me know. We'll go together to that conference. I want to check it out, especially if it's in
Oh,
Toronto.
yeah, yeah, for sure. Yeah, I should have actually. Yeah, next
Yeah.
time for sure. I let you know too.
I noticed, I think Cursor is what I use for my vibe coding sometimes, and usually it's on Claude, but it also has the, I think, DeepSeek option. Last time I checked, maybe I'm mistaken, but it's really easily like quickly, people started like, okay, integrating that. And we were developing an app just for fun the other week, and we were comparing the token prices, OpenAI versus DeepSeek, and DeepSeek was so much cheaper as far as like how many tokens. It's just like wow, like this kind of economics opens up to you once you start, when you need to like develop like AI app, you start purchasing tokens, and then you're trying to find the best deal, and that's where it clicks with you. Like okay, like there might be some competition going on here that is extremely, extremely, I don't know, I think it's like aggressive, right? So, but let's go back to the layered infrastructure. Why do you think this layer of infrastructure has been overlooked until now? Like, um, yeah, like why, if it's cheaper, if it's better, if it's like requires less, like what's happening? Why didn't we start with that?
So in the decentralized world, I think we kind of have a shift maybe in the past 2 years that people have started to build real applications. Like, for example, companies like Grass, it's a very big company. They collect raw data. They have a desktop app and Google Chrome extension that people install, and then Grass uses their bandwidth to download something. This kind of like type of like call it breakthrough in a way. This has started in the crypto blockchain domain just like 2 years ago. Before that, like blockchain crypto was all about like mostly like DeFi and like buying like different tokens, like starting from Bitcoin, Ethereum, all of that. But nobody was kind of like until again 2 years ago, focusing on real applications of wow, how blockchain can do other stuff. There's a lot of also focus on real world assets, but
Hmm.
again, I put that under the finance application of blockchain. So these
Right.
other real application of blockchains, especially how a distributed network can easily run and distribute rewards between the nodes that run it using blockchain, this is very new. So that's why, like at least in my opinion, nobody has thought about doing like what Heisenberg is doing yet. There are players in the centralized domain, like as I said, AWS SageMaker is one that basically also provides like tools for builders to transfer raw data into AI-ready data and always keep it up to date. So those tools are out there, but the the blockchain domain wasn't, maybe like I should say, wasn't mature enough until very recently that people start to think about these real applications with real distribution, all of that.
I see. And as far as like the new stuff that you are excited about, like the next big thing, upcoming milestone or launch, like what is something that gets you really excited in the field?
So we are releasing our desktop app to through our waitlist. We have like waitlist with a lot of users now. So we're gonna start onboarding them in a small batches at the beginning from early April. That's our plan to start onboarding the early adapters. I'm running a Heisenberg node right now on my computer, but we're gonna like basically onboard based on our waitlist users from early April. That's definitely something I'm very excited about. I'm sure there will be something that we're gonna fix down the road. Like that's why we have these early releases, and obviously people who also install it first, they will get reward first and sooner than later. So that's kind of the motivation for them. And then working with our early adapters. Like one example, your boxing example you mentioned,
Right.
we do work with a company that has very similar mindset about different agents they have. So I'm very excited to see what they can build with our technology, with the data agent that we offer, and how they can supercharge, enhance their agents.
That's amazing. And it's very exciting that Heisenberg is about to do some beta launch and work with the waitlist. I know there's a waitlist that is very popular right now, and everyone should check it out. I'll drop some links to the waitlist as well to Heisenberg. Get on that waitlist as soon as possible. Mehdi, I wanted to ask you as a leader, as a technical founder, you're into the startup thing, but at the same time you're a professor. You work at two universities. And you know, you have a lot of things going on. How do you, like on the personal level, how do you stay focused and not getting distracted, especially in the field of AI, where there's like every time there's something new, there's this hype, that hype. How do you maintain that laser focus for Heisenberg?
So if you believe in what you are building and you keep talking to real customers who have real needs, that kind of like make you not get distracted by the hype. To me, like people who get distracted, they don't have like a clear vision, or maybe they don't have a real product with real customers. So that's why they get distracted. Obviously, for me, like sometimes I see the price of Bitcoin going up and down. It obviously affects like the entire crypto space immediately, no matter what you build. When Bitcoin goes down, all tokens go down. And obviously, like it's a distraction, for example, one example of this, so many distraction you can get. But if you have a clear vision, if you know what exactly you want to do and you know the benefit that it brings to the community, to the people, to your customers, for us, especially to our early adapters for us, that like keeps you not get distracted. That's at least for me, that's how it works. And I'm very happy about it, yeah, the way it is right now.
Absolutely. And for our listeners, for people who are, Mehdi is mentioning crypto, people who run Node will get rewards that will convert into crypto. And so Heisenberg will be integrated with crypto significantly in that sense. And that's why it's kind of like so intertwined with the crypto market as well, which is very, very exciting. Mehdi, last question to you. What would you tell to a young technical founder who's trying to build something meaningful in AI right now? I know Heisenberg Network is backed by VCs and it's like it's funded and all. Like, how's that for you? What would be your advice for someone who wants to replicate that success?
I would say if you have a rough idea, talk to people, talk to any potential customers to see how you can shape that rough idea into something that's actually useful. And I assume that you're talking about people who want to do real stuff, not people that just want to do something for fun. If you want to do something real, something useful, something that hopefully becomes big, the rough idea, you have to talk to customers. You have to talk to your early adapters to see what they really need. And at the beginning, it's much easier to pivot than 6 months, a year down the road. And build a small proof of concept. Nowadays, it's much easier with all the tools that we have access to build a proof of concept, to get feedback from users, and then maybe like pivot based on that. And if you do have like an idea and you already have customers lined up saying that, oh, I'm going to use your product as soon as you release it, then get funding is also 100 times easier than just the idea. So try to find that product market fit. It's probably the hardest thing to do when you do a startup, to find product market fit. And it only comes if you talk to people. If you're sitting in a corner writing code for yourself, no matter how sophisticated your coding skills is, your idea is, if you don't talk to people to find who's going to actually use my product, I don't think the chance of success is very high. I think it actually would be pretty low.
There you go, Dr. Mehdi Kargar. Thank you so much for your time. Um, how can we access Heisenberg so that, or also like how we can get in touch with you? Can you please let us know?
So the website is here on my cap, heisenberg.so. And also shoot us an email, contact@heisenberg.so. That also would definitely get us in touch with us. But I think the best is just go check our website, and Samir, you will kindly add a link to
Absolutely.
onboarding the people on our wait list. That would be also great.
Yes, I will add all the links, especially the link to the waitlist, to the very, very, very hot waitlist right now. The signups are pouring in as far as I heard, and I will also provide links to the website and the social media as well. Heisenberg Network on LinkedIn and on X. Well, Dr. Kargar, thank you so much for this conversation. I really, really love how we covered so much stuff, and I hope to see you again for part two, because for the part two, I want to focus a lot on the crypto side of Heisenberg,
Absolutely.
and how how the supply side, the people who are providing their compute can earn with Heisenberg passively.
Thank you. Pleasure talking to you, Samir. Thank you.
Thank you very much, sir, and take care.
Take care.